Scalene Triangle. A scalene triangle has 3 sides of different lengths, so all 3 interior angles are different as well. Since no sides are equal, it has no line of symmetry, making it the most irregular type of triangle. This shape is common in surveying, engineering, and natural structures where measurements rarely match perfectly. If the sides are represented by A, B, and C, the perimeter is P equals A plus B plus C. Because the height is not always known, its area is usually calculated using Heron's formula. Area equals the square root of S times S minus A times S minus B times S minus C, where S equals a plus B plus C over 2 is the semi-perimeter. This formula allows the area to be calculated using only the 3 side lengths. Isosceles triangle. An isosceles triangle has 2 equal sides and 1 different side. The angles opposite the equal sides are always equal, creating a naturally balanced and symmetrical shape. A line drawn from the top vertex to the base acts as the altitude, median, angle bisector, and perpendicular bisector all at once. If the equal sides are A and the base is B, the perimeter is P equals 2O plus B. The area is area equals 1/2 times B times H, where H is the perpendicular height. If only the side lengths are known, the height can be found using H equals the square root of a squared minus B squared over 4. Equilateral triangle. An equilateral triangle has 3 equal sides and 3 equal angles of exactly 60 degrees. It is the most symmetrical triangle and one of the strongest geometric shapes because forces are distributed evenly across all sides. If every side has length A, the perimeter is P equals 3A. The height is H equals square root of 3 over 2, A, and substituting this into the area formula gives area equals square root of 3 over 4, squared. The centroid, circumcenter, incenter, and orthocenter all meet at the same point, making it unique among all triangles. Acute triangle. An acute triangle is defined by its angles rather than its sides. Every interior angle is less than 90 degrees, giving the triangle a compact shape. It may be scalene, isosceles, or equilateral. Since its side lengths can vary, there is no single perimeter formula, so the perimeter is P equals A plus B plus C. The area is area equals 1/2 times B times H. In every acute triangle, the centroid, circumcenter, incenter, and orthocenter all lie inside the triangle, making it an important case in geometry. Right triangle. A right triangle contains one angle equal to exactly 90 degrees. The side opposite this angle is called the hypotenuse and is always the longest side. This triangle forms the foundation of trigonometry and appears throughout engineering, architecture, navigation, and physics. If perpendicular sides are A and B and the hypotenuse is C, then C squared equals a squared plus B squared, according to the Pythagorean Theorem. The perimeter is P equals A plus B plus C, and the area is area equals 1/2 times A times B, because the 2 perpendicular sides naturally form the base and height. Obtuse triangle. An obtuse triangle has one interior angle greater than 90 degrees, while the other 2 remain acute. The side opposite the obtuse angle is always the longest. Like an acute triangle, its side lengths can vary, so the perimeter is P equals A plus B plus C. The area remains area equals 1/2 times B times H, although the perpendicular height may fall outside the triangle. The law of cosinus, C squared equals a squared plus B squared minus 2AB. Cosine C is often used to study and classify obtuse triangles. Right isosceles triangle. A right isosceles triangle combines the properties of both a right triangle and an isosceles triangle. It has one 90-degree angle and 2 equal legs, producing 2 remaining angles of 45 degrees each. If each equal side has length L, the hypotenuse becomes a square root of 2. The perimeter is P equals 2A plus a square root of 2, and the area is area equals A squared over 2. This special triangle appears frequently in drafting, architecture, and computer graphics because of its simple mathematical proportions. Acute Isosceles Triangle. An acute isosceles triangle has two equal sides, and all three interior angles smaller than 90 degrees. It combines symmetry with the compact shape of an acute triangle. If the equal sides are AO and the base is B, the perimeter is P equals 2A plus B, and the area is area equals 1/2 times B times H, where H equals the square root of a squared minus B squared over 4. Because of its symmetry, it is often used in structural and decorative designs. Obtuse Isosceles Triangle. An obtuse isosceles triangle also has two equal sides, but the angle between them is greater than 90 degrees. Even with a wider apex angle, the two base angles remain equal. If the equal sides are A and the base is B, the perimeter is P equals 2A plus B. The area is area equals 1/2 times B times H, and the height is H equals the square root of a squared minus B squared over 4. This shape appears in geometry whenever symmetry and wide angles are required together. Acute Scalene Triangle. An acute scalene triangle has 3 unequal sides and 3 acute angles. It contains no symmetry, making every side and angle unique. The perimeter is P equals A plus B plus C. Since the height is often unknown, its area is commonly found using Heron's formula area equals the square root of SS minus A, S minus B minus C, where S equals L plus B plus C over 2. This triangle represents one of the most general cases studied in geometry. Right scalene triangle. A right scalene triangle has one right angle and 3 sides of different lengths. Unlike the right isosceles triangle, none of its sides are equal. It follows the Pythagorean relationship c squared equals a squared plus b squared. The perimeter is P equals a plus B plus C, and the area is area equals 1/2 times A times B. This is the most common type of right triangle encountered in practical measurement and engineering problems. Obtuse Scalene Triangle. An obtuse scalene triangle has one angle greater than 90 degrees and 3 unequal sides. Its irregular shape makes it one of the most flexible triangles for real-world applications. The perimeter is P equals a plus B plus C. The area can be calculated using area equals 1/2 times B times H when the height is known, or by Heron's formula. Area equals the square root of the minus A, S minus B, S minus C, when only the side lengths are available. The law of cosinus is also widely used to analyze this triangle because it accurately relates its unequal sides and obtuse angle